In 1922, Albert Einstein released the first edition of his book, outlining the general theory of relativity, which included the hypothesis of black holes. The most extreme things in the universe are black holes. All massive galaxies are believed to have supermassive versions of these very dense objects in their centers. Stellar mass black holes are far more common, weighing between 5 and 100 times as much as the Sun. In fact, the Milky Way alone is thought to contain 100 million stellar mass black holes. Astronomers have found the closest black hole to Earth, which they have named Gaia BH1. They utilized the Gemini North Telescope in Hawaii, one of the twin telescopes of the International Gemini Observatory, which is run by NORLab of the National Science Foundation, to find it. Gaia BH1 is a dormant black hole in the constellation of Ophiuchus that is around 1,600 light-years away and about 10 times as big as the Sun. This means that it is 3 times as close to Earth than the previous record holder, an X-ray binary in the constellation Monoceros. Precise observations of the behavior of the black hole's companion, a star similar to the Sun that circles the black hole at around the same distance as the Earth orbits the Sun, led to the new discovery. If you take the solar system, replace the Sun with a black hole, and the Earth with the Sun, you now have this system. Even though there have been several reports of such systems being detected, virtually all of these reports have now been debunked. In our galaxy, this is the first clear indication of a Sun-like star in a large orbit around a stellar mass black hole. The few stellar mass black holes that have been found were discovered by their intense interactions with a companion star, despite the fact that there are probably millions of them wandering the Milky Way galaxy. As matter from a neighboring star spirals towards a black hole, it gets superheated and emits intense X-rays and material jets. When a black hole is inactive, meaning not actively feeding, it simply merges into its surroundings. In the past 4 years, astronomers have been searching for dormant black holes using a variety of datasets and techniques. This is the first time the search has yielded results, despite the fact that past searches and many others have brought up a plethora of binary systems that pass for black holes. Data from the Gaia spacecraft of the European Space Agency were first examined by the researchers to determine the system's potential presence of a black hole. Gaia caught the minor irregularities in the star's movement brought on by an invisible huge object. Astronomers used the Gemini Multi-Object Spectrograph instrument on Gemini North to study the system in further detail. This device produced accurate measurements of the orbital period and the velocity of the companion star as it circled the black hole. The team was able to identify the central body as a black hole around 10 times as big as our Sun, thanks to the Gemini follow-up observations, which were essential in putting constraints on the orbital velocity and therefore masses of the 2 components in the binary system. Beyond a shadow of a doubt, our Gemini follow-up measurements prove that the binary includes both a regular star and at least 1 inactive black hole. No reasonable astrophysical explanation for the observed orbit of the system that does not include at least 1 black hole was found by the team. The team depended on Gemini North's exceptional observational talents, as well as Gemini's capacity to provide data on short notice, since they had a limited window of time in which to conduct their follow-up observations. Only 1 week had passed since the 2 objects were furthest apart in their orbits, when we first discovered that the system had a black hole. For precise mass estimations in a binary system, measurements at this stage are crucial. The success of the initiative depended heavily on Gemini's capacity to deliver observations on a short timetable. We would have been forced to wait another year if we had missed that brief opportunity. The unique configuration of the Gaia BH1 system is difficult to explain using astronomers' existing models of the progress of binary systems. The progenitor star, which ultimately evolved into the newly discovered black hole, would have had a mass at least 20 times that of the Sun. This means that it wouldn't have lasted more than a few million years. If both stars had formed simultaneously, This enormous star would have swiftly evolved into a supergiant, inflating and swallowing the other star before it had a chance to evolve into a proper main-sequence star like our Sun, which burns hydrogen. The findings of the black hole pair suggest that the solar mass star could not have survived that incident and ended up as an apparently normal star. The solar mass star should have ended up on an orbit that is considerably closer to what is actually seen, according to all theoretical models that do allow for survival. This may imply that there are significant knowledge gaps regarding the formation and evolution of black holes in binary systems, as well as the presence of an undiscovered population of dormant black holes in binary systems. It's intriguing that traditional binary evolution models have a hard time modeling this system. It raises a number of issues, including how many of these latent black holes exist and how this binary system came to be. In addition to providing solid proof for the closest black hole discovered so far, Gemini North, a component of a network of space and ground-based observatories, has also discovered the first pure black hole system, free of the normal heated gas interacting with the black hole. While this may foreshadow the discovery of the projected number of hibernating black holes in our galaxy in the future, the findings also raise the intriguing question of why the partner star in this binary system is so ordinary given its shared past with its strange neighbor. Some of the cosmos' most intriguing and perplexing things are black holes. Intense gravity, which is a black hole's defining feature, also makes it challenging to research. A black hole's whole mass is gathered in a small area that is bordered by a line known as the event horizon. Even light cannot get through the barrier and return to the outer realm. A black hole is invisible in and of itself, but when gas moves around it, it warms up and paradoxically becomes some of the brightest objects in the universe. Black holes continue to be both a concept that has been solved and a mystery for those on Earth who are curious. Since an English country parson named John Michell initially proposed the startling idea in 1783, countless black holes have since been identified across the cosmos. Thanks for watching. Don't forget to like the video and subscribe to our channel for more discoveries in space. Until next time.